Okay, so Algebra 1 here, we're looking at section 5.4. We've been solving some inequalities in the first half of the chapter. Now you can see we're looking at solving compound inequalities. Compound meaning they're being put together. We're going to have two different words we're putting together with and we're going to put together with or. So we'll start off here, you can see with and. Okay, so solving compounding inequalities, section 5.4. The and, as we know, that means both. So both requirements have to be met. Okay. If you're told to wear you maroon and gold to school, that means you're supposed to wear both, right? If you wear maroon or gold, then it's one or the other. Okay. So both requirements have to be met if you say the word and. So for example, if I say something like x is greater than or equal to 3 and x has to be less than 7. Okay, so both of these requirements have to be met. Okay, so if I say the x is 4, that fits in this requirement. It meets this requirement that's greater than or equal to 3, and it meets this requirement being less than 7. Okay, but if I say 8 is greater than or equal to 3, it meets that one, but it doesn't meet this one. Okay, so it has to meet both requirements to be true. If we graph this out, what that ends up looking like is something like this. It has to be greater than or equal to 3, so everything to the right of it until you get to here. So it's everything between 3 and 7, all right? Obviously, we have an open circle there because just like we talked about in the first half of the chapter, you can't use 7. That doesn't meet the requirement, okay? So it looks something like that. So it basically looks like that, it goes across, and that's what you're looking for, okay? So an and will usually look something like that, where you have kind of in between those two values. Let's take a look at this looks like by solving some. Okay. So if I solve this one, again, you can see we have y is less than 3, greater than negative 11, and y minus 2 less than or equal to negative 8. So we're just going to solve both of these, just like we would have solved them in the first half. It's just kind of like solving two of them in the same problem. So I'm going to add 3 to both sides. That cancels this off, leaving me y is greater than or equal to negative 8 plus negative 11 plus 3 gives me negative 8. Okay. Then we'll solve this one. Let's add 2 to both sides. By adding 2 to both sides, again, that cancels off, leaving me y is less than or equal to negative 8 plus 2 gives me negative 6. So y has to be greater than or equal to negative 8, but less than or equal to negative 6. So I'll make my graph here. All right, so kind of like before, we're going to graph out our solution sets. We're going to have filled in circles on both of them because they're both or equal to, and going in between there. All right. This one over here. This one that looks a little bit different. Notice we don't see the word and. But what this really says is 7 is less than x plus 2, and x plus 2 is less than or equal to 11. It's like they just push them together. So when we read this, we're actually reading it that way, but we just don't see the word and. Now, you could split it up like this and solve each one separately like we did there, or you can just treat it like having 3 parts to the equation. So I'm going to try and get x by itself in the middle. So I'm just going to subtract 2 from everything. So 7 minus 2 gives me 5 is less than x, which is less than or equal to 9. So it's everything in between 5 and 9. So again, here's 5, here's 9. Open circle here because it's just there to there. Remember, even though it says less than, it's actually read from the variable, so x is actually greater than 5. That's why I went to the right of 5, and then less than or equal to 9, left of 9. Okay, so that's kind of what an and problem looks like. Here's a couple of them for you to try out. Okay, so we'll give you a couple minutes, we'll pause the video, and then we'll come back and work them. Okay, hopefully you had a chance to work those out. So again, I'm just going to solve these out and I'm going to graph them onto a number line. So I'm going to add 8 to both sides. That gives me p is greater than or equal to 22, right? And then I'm going to add 14 to both of these. So p is less than or equal to, what we got, 16 there. So greater than or equal to 22, less, oops, I did that wrong, sorry. This should have been just a 4. I was looking at that wrong. Sorry about that. This probably worked out kind of funny, didn't it? So 4 plus 8, that's 12. Okay. I wrote it down wrong on my notes here. All right. So then we looked here. Sorry about that. So greater than or equal to 12, less than or equal to 16. So we have a filled in circle on both ends again, looking something like that. Okay. Sorry about that. That should have been just 4 there, not 14, which makes a difference. Okay. So if we do that properly, if I wrote it down properly, it'll look something like that. All right. Number 2, again, kind of like the last one, I'm just going to add 3 to everything. That leaves me 1 is less than or equal to x, which is less than or equal to 7. So everything in between 1 and 7, we'd have a closed circle on this end this time, open circle over there. So everything between 1 and 7 is what gives that to you. All right, so that's the first type of problem. The second type of problem here is or. Or means either. All right, so again, if it says to wear maroon or gold, as long as you're wearing one or the other, that's okay. You don't have to do both of them. So it will look something like this. X is less than 3 or x is greater than or equal to 8. Okay, so if it looks like that, these will typically go away from each other. So x is less than 3 looks like that. Greater than or equal to 8 looks like this. Okay, so going away from each other. So if I pick a number over here, that'll make that one true. If I pick a number over here, it'll make that one true. If it's in between here, like 0, that won't make either one of them true. And so those are the requirements to make them true. So that's usually what an OR will look like. Again, we'll look at some special cases where that doesn't happen, but that's typically what an OR will look like. So let's take a look at this one here. So again, on these, you will see the word or. Okay, you'll always see or. Sometimes you see and, sometimes you don't, but this you'll always see or. So we're just going to solve this. So I had negative 2m plus 7 greater than or equal to 13. I'm just going to subtract 7 from both sides. That gives me negative 2m is greater than or equal to 6. We're going to divide by negative 2. Now remember, we're still working with inequalities. Since we're dividing by a negative 2, we have to switch the inequality. So it's going to go greater than or equal to less than or equal to. And we get negative 3. All right. Over here, I'm going to subtract 12 from both sides. That leaves me 5m is greater than or equal to 25. Then I'll divide both sides by 5, and I get m is greater than 5. So again, remember, it's or. We expect them to go away from each other, and that's exactly what happened here. So we have less than or equal to negative 3 going that way, greater than 5 going that way. So that's typically what we see when we have an or problem. Again, we just solve each one separately, graph them out on the same number line, and there's our solution set. Okay. Let's have you try another one of those. So this will be with an or problem here. So go ahead and work this one out here. Again, we'll pause the video here for a second and work that one out. Graph it onto a number line again. Okay, hopefully you had a second there to work that out. All right, so again, we're just going to solve each one separately. So here I'm going to add 7 to both sides. That leaves me 4k is less than or equal to 32. Then I'll divide both sides by 4, and I get k is less than or equal to 8. Okay. On this one, I'm going to divide both sides by 3. So I get k is greater than or equal to 11. So less than or equal to 8, greater than or equal to 11. We're going to have filled in circles on both sides, going away from each other. Less than or equal to 8, greater than or equal to 11. Okay? All right. Some what ifs. Again, sometimes things work out funny. On that first example that I gave you, and I didn't write it correctly, it probably worked out kind of funny. And sometimes they're meant to do that. That one I didn't mean to do it on. But on this one, some things happen. Okay? So let's look at some what ifs. So sometimes when you're solving it, maybe it's an and problem and it looks like this. So on this, we have x is less than 8. As I go to graph this, x is less than 8 looks like this. X is greater than or equal to 12 looks like this. But that looks like an or graph. But we have the word and. So since we have the word and there's nothing in between there, it's kind of marked the wrong way. This means no solution. Okay? Because The graph's going the wrong way. They're not overlapping. All right. There's no way you can meet both of those requirements, being less than 8 and greater than 12. There's no number that meets that requirement. Okay. This one, x is greater than or equal to 4 or x is less than 6. So again, if I go to graph this, there's 4, here's 6, greater than or equal to 4 goes this way, less than or equal to 6 goes this way. Everything's covered. There's not a number you can pick that won't make at least one of these true, and sometimes it'll make both of them true. But everything's covered. So it's an or. They went towards each other like we'd expect on an and, so that means all solutions work. Okay. So
the building come to the
again,
office, please.
it looks like
come to the office.
An and problem, but it was an or, and that's why we end up with all solutions. This one looked like an or, but as an and, so is no solutions. All right. As we look at this one, all right, we have, again, same idea. Let's just graph and see what it looks like. We have less than or equal to 5, so we're going like that. We have less than 9, so it looks like this. Again, we're looking where it meets both requirements. If I pick a number over here, it doesn't make either one of them true. If I pick a number here, it only makes this one true. If I pick a number over here, it makes this one true, both of them true. And so we're looking for that member and as where both of them are true. So this one, this doesn't even matter. It's this one that makes the difference. So if it's an and, it's where they're overlapping, which is actually the shorter of the two graphs. That's the one that matters. The other one doesn't count. As long as it's less than or equal to 5, okay, then this one's already going to be met. Okay, so the shorter graph, if it's an and they're going the same direction. If it's an or and they're going the same direction, so less than or equal to 5, less than 9, okay? Now again, as long as it meets one of the requirements, the or is good. Over here, it meets both of them, so that's okay. Over here, it meets that one, so that's okay. Over here, it doesn't meet anything. So as long as it's here, we're good. This one doesn't even matter. So on that one, we're actually going to use on an or, we're going to use the longer graph if they're going the same direction, okay? So again, those are some what ifs. Those are some things. Most of the time, that's not going to happen. But there's a few times that they give it to you where they're either going the same way or they're going the wrong way for what type of problem it is. And then you have to interpret what type it is. So if it's an and problem, they're going away from each other, no solution. If it's an or and they're overlapping, all solutions. If they're going the same direction, on an and, you use the shorter of the graphs. On the or, you're going to use the longer of the graph, so only this one matters. Okay, so again, those are kind of some things not always happening, but that could happen on those. All right, so that's solving combined inequalities. Your homework on page 308 is 2 through 14 even.